morning once again, students. We are going to continue with the indices and logarithms. Last time we dealt with the indices. We are going to deal with the logarithm part of the topic. Now, logarithms and indices have something in common, and the two put together as the main topic. Now, when we say logarithms, the logarithm of a number to a particular base is the power to which the base must be raised to get that number. And it is mathematically written as log . It is mathematically written as log A to base B equal to M. So the log A here, base B, means the power to which this B must be raised to get A, and that power is the M. So in index form, we can express this as B raised to the power M, E raised to the power M equal to E. So that's the meaning of logarithms. What it means is that when you are given 3 raised to the power 2 equal to 9, then this can be expressed in logarithm as I was saying, when we have 3 raised to the power 2 equal to 9, in logarithms, it means the log of 9 to base 3 equal to 2. What it means is that the power to which 3 must be raised to give us 9 is 2. It's as simple as that. In general, let's say we have P raised to the power A equal to M. In logarithms, we can simply say the log of M to base P is equal to A. That means the power to which P must be raised to give us M is A. Now let's solve some examples based on the definition. Let's say you are asked to evaluate log 64 to base 4. By the definition, what this means is that the power to which the base 4 must be raised to give us 64. So since we don't know the power, we let a variable represent the power. So we continue by saying, we say let log 64 base 4 be equal to, say, x. Then we now express this in index form. As I said earlier, logarithms and index, they intermarry. Let me put it that way. So we now express this whole thing in index form. So in index form, it will mean 4 raised to the power x is equal to 64. Then just as the way we solved equations involving indices, we try to express the 64 to the same base as the 4. So this means we are going to get 4 raised to the power x being equal to 4 raised to the power 3. Then, having gotten the bases to be the same, we can go ahead and compare the exponents and conclude that the exponents are the same. So we will end up getting x being equal to 3. What it means is that it is 4 raised to the power 3, which will give you 64. Now I would like you to go and try this. Find the log of the log of 0.001 to base 10. In other words, evaluate. Then the second trial question will be evaluate the log of 27√3 to base √3. Okay. Now let's move on. There are some important points that you should note under logarithms. And the points are: first, whenever you are to find the log of a number, say x, to a particular base, let's say a, and x is less than 0, that logarithm does not exist, or that number will not exist. Why? If you look at the definition, we are being told that the logarithm of a number, let's say x, is the power to which the base a must be raised to give us x. Now, is there any power of a negative that will always give you a certain logarithm? No. Because of that, we say the logarithm of a negative number does not exist. Don't forget, whenever x is less than 0, it means the number is a negative number. Another point to note is the log of 1 to any base is always equal to 0. Why? Because if we are to explain this as it is put here, what number or what power must a be raised to give us 1? Of course, we know that any number raised to the power 0, that's from the properties of indices, is always equal to 1. And I think this was proved under indices. Now, the third point to note. Whenever you are to find the log of a proper fraction, the given answer will always be negative. So in mathematics, we say if we are to find the log of x to a certain base a, don't forget a is a variable, it can stand for any number, and x2 is a variable, but x is a proper fraction, such that this x is greater than 0 but is less than 1. In effect, it is supposed to be 0 less than x and x less than 1. You always get a proper fraction. So any logarithm of a proper fraction will always give you a negative figure. Example, let's say you are to find the log of 1/3 to the base 2. You see that 1/3 here is less than 1 but is greater than 0. Hence, it satisfies the condition here. So, if we are to express this 1/3 in index form, it will be the log of 3 raised to the power -1 to base 2. Then, if you say if you should let the log of 3 raised to the power -1 to base 2 be equal to a variable y, then in index form we will end up getting 2 raised to the power y being equal to 3 raised to the power -1. Hence the value. Thank you. Now let's move on to the next point to note. That's note 4. Point 4, let me be precise. Now the log of 0 to any base, say a, is undefined. That means mathematically the log of any power to, the log of 0 to any base does not exist. One may ask why. Now from the definition of logarithms, we said the power to which the base must be raised to get that number. So in this case, what power must a be raised to get 0? In reality, is there any number that you can raise to a particular power to get 0? Point to note is that the log of 0 to any base does not exist. In mathematics, we say log 0 to any base a is undefined. Then one may ask why? Why is it that it doesn't exist? From the definition of logarithm, we say the log of a certain number to a certain base is the power to which the base must be raised to give us the number. And here the number concerned here is 0. So is there any power to which a certain number or a certain base can be raised to give us 0? No. No, there is no such number, because even if we have a raised to the power, we take a raised to the power 0 itself. That one is 1. So there's no way we can get such a number. So because of that, we say mathematically it does not exist or is undefined. So to prove it, you can punch on your calculator, find the log of 0 to any base. And the calculator will tell you mathematical error. Now let's come to the fifth point to note. Now the log of any number to the same base as the number is always equal to 1. The log of any number to the same base as the number is always equal to 1. So let's say you have the log of a to base a is equal to 1. Why? Because it is only a raised to the power 1 that will give you a and nothing else. Now let's move on. So all this we did basically deals with the definition of logarithms. We are now moving on to the laws of logarithms, just as we had the laws of indices. In logarithms, we have 4 main laws, and we are going to deal with them one by one. And of course, they will be followed by their respective proofs.